on this one, I rewrote in terms of math symbols. We want, assuming, of course, the f of xy is 8x plus 4y squared. Otherwise, y would just multiply by 2 here in this original problem. So it's going to be 64x squared plus 64xy plus 16y squared. So we have the double integral where the outer limit is integral with respect to dy, and the y1 and y2 upper limit and lower limits are constants, and then the inner integral with respect to dx is going to be x1 have lower limit x1, which is a function of y, and also x2, which is also a function of y. So I did all this beforehand, and let's summarize the region in this diagram, because once we understand the region, then it's easy to pull out those limits of integration. So I have here the 3 points, a is equals minus 1, 0, b is equals 1, 0, c, and then I also highlighted the horizontal region y equals 1 and y equals 0. Now, the only missing link is to connect the dots. That is, what's the equation line going from A to C? Normally, in standard algebra, is y equals 1x plus 1. But we want it in terms of x, in terms of y. So it will be, we write this as x equals y minus 1. So this is the equation, this line here, x is equal to y minus 1. And then similar for the line connecting point B or C to B or B to C, normally we write this as y equals minus x, or we can have it as x is equals to minus y plus. So those are all the missing ingredients we need to fill out in the description of the region. R is the collection of xy such that y is between 0 and 1, parentheses, and then, of course, y, or x now, is between this line and this line, or written as x is greater than or equals to y minus 1 and less than or equals to minus y plus 1. So our double integral have the following limits. Y1 is equal to 0, y2 is equal to 0, and subscript here, x1 lower limit is y minus 1, upper limit is minus y plus 1, and here's our function, dx, and then moving the subscripts of the x's and the y's, we have this straightforward double integral here. Now, to kickstart it, if we're integrating this first term with respect to dx, other terms with y are treated as constant. So it's indefinite equals 63 x cubed plus 64 over 2x squared plus times y plus 16y squared x, and evaluate that at the upper limit. We have that's equals to y equals to that, and then evaluate that at and minus the evaluation at the lower limit, which is y minus 1. And that's it. I kind of stopped there because my colleague up there says I'm really out of time. He says, but not to leave you stranded here, here's this complete evaluation is equals 40 over 3. We could continue on this, but I think this is just pure drudgery. Once you know how to set it up, none of this integral here is mind-boggling, right? So happy New Year's, and I will stop it there.